So what are quartiles really useful for? So quartiles are kind of useful when we want to represent the data in terms of a box and whiskers plot. So the first thing that we want to do is create the 5-number summary. So the 5-number summary involves 5 different things. It involves the minimum value, the first quartile, the second and third quartile, and also the maximum value. So this is going to be really useful because sometimes the quartiles can tell us whether something can be an outlier or not, and I'll explain how we do that. So this is first a regular box plot. Just a regular box plot is just a visual representation of all the data points, including the points placed far left or far right in the data set. So this box plot actually includes the outliers. So as you can tell, here is the minimum value, the maximum value, and then the box is created by putting in the first, the second, so this should be actually Q2 or the median, and the Q3. So the sides of the box and the middle of the box is just going to be the quartiles. Now, the box plot is good, but the thing is, like, let's say we had like the numbers 1 through 10 somewhere around here, and then we had an outlier of 100. Well, our box plot then would look something like this, because if all the numbers between 1 to 10 are there, well, the number 100 is going to be way out there, and now what we have is this elongated fence. What we do instead of the regular box plot, instead we do this modified box plot. So this modified box plot does not include the outliers. And I want you guys to write a star on this, because I will make you do a box plot by hand on the exam. So it doesn't include any of the outliers. Instead, the outliers are represented as points beyond the whiskers. Okay. So let me just explain a little bit of what this is. So there's something called the lower and upper fences, which are right here. So the lower and upper fences, basically what it is, if I take the first quartile and subtract it by this IQR. So let me first tell you what this IQR is with a different color. So the IQR is just a range, the interquartile range between the Q1 and Q3. So it's the basically how far are the quartiles from each other, Q3 and Q1. So that length, so basically here, this part is going to be your IQR, is the range between here's Q1 and here's Q3. So how far are these two away from each other? Now that length, so the distance between Q1 and Q3. So if I take Q1 and I subtract it by the IQR, which is the length between Q1 and Q3, right? I'm probably going to get some Q1 minus IQR is probably going to give me that. But if I instead, what I do is I'm going to multiply it by a little bit more than 1.5, or I'm going to multiply it by 1.5. So multiply this range by a little bit more. And what that tells me is that this entire length tells me that these are all the good values. Anything outside of that, outside of these fences, is going to be considered an outlier. So this is where these formulas kind of come from. You just really need to be able to do it. Now, why 1.5? Well, it can be anything that you want. So if you want if you want to denote an outlier to be more than twice the IQR, then you can do that if you want to. It really just depends, but 1.5 is the most used number, and it's a really good estimate to identify outliers. So if I know that my outliers lie between or lie outside of these fences, then we know that those can be outliers. So let me show you a little bit on how we're going to graph these. So I'm going to go ahead and make sure that you know this also. You can write it on your little note sheet when we do your exam. But let me do an example. That way you guys can all know how exactly we're doing this. So this is a very good problem where I might ask on the exam. So given the following data, find the 5-number summary. So the first thing that we're going to do is find the 5-number summary. And remember, the 5-number summary involves me finding the minimum value, all the quartiles, and the maximum value. So I want to figure out what this is. So I'm going to first order them. So what is the lowest number? So the lowest number is 22 in this case. So 22 is the lowest number. So then after that, I think it can be 34, I believe. Okay. Just kidding, not 34. It's going to be 25 because we have a 25 right here. Then we have 34. Okay, so get rid of the 34. Then we have 35. So get rid of that. We have two 41s. This is so painful. Then we have a 46 and a 46. Okay, then we have 47, 49, 2 54s, a 59, and an 87. Okay, I think that's all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, good. All right, so this is really painful, numbering everything. And if you feel like you're going to make a mistake, just use your calculator. Calculator is great. You can just immediately do that. That might be a little bit faster. I don't know why I didn't do the calculator, but I should have. So let's see. So the first thing that I see, the minimum and maximum is pretty easy. So the min is just 22 and the maximum is just going to be 87. That's pretty simple. Now the first thing that we're going to do, we're going to go ahead and separate this. So let's find your Q2. So let's find our median. Okay. So let me see which one is going to be our Q2. And I try to do these underline each number so that I can try to identify who the middle number is. And in this case, I can see that the middle number is going to be 46. Okay. So I'll write it here too. All right. Now what we're going to do, we're going to go ahead and take the mean. Just kidding. We're going to find the quartile. So Q1. All right, so now since both of these were in the middle, I'm just going to go ahead and separate it by halves because it's really easy to just do it. So now this is going to be my bottom half. This is going to be my top half. So from the bottom half, let me see which one's going to be the middle one. So it's going to be 35 in this case. So Q1 is going to be 35. All right. And then Q3 is going to be the middle of whatever these were. So let me just take the middle number. In this case, it's going to be 54. So Q3 is 54. So here is my 5-number summary. Okay, so we got everything that we needed. All right, and then you can use your calculator to double check that these are actually the right answers. Okay, so now the next thing that we want to do is find the lower fence and the upper fence. Okay, so the lower fence is going to be, if we look back up, the lower fence is going to be Q1 minus 1.5 times the IQR. So, oh, what did I do? Oh, okay. So first, let me figure out what the IQR is. So IQR is going to be the inner quartile range, which is the difference between Q3 and Q1. Okay, so this is going to be the difference between 54 and 35. So we're going to take 54 and subtract it to 35. And what that's going to give me 19. All right, so what I'm going to do, I'm going to take Q1 minus 1.5 times the IQR. So Q1 was just equal to 35 minus 1.5 times 19. And then the upper fence is going to be your Q3 minus 1.5 times the IQR. This is going to be 54 minus 1.5 times 19. Okay, so I'm going to put that in my calculator. 35 minus 1.5 times 19. I'm going to get 6.5 here. And I'm going to do 54 minus 1.5 times 19 here. And I'm going to get 25.5. So these are my fences. Basically what this means is that if I have any number that's outside of these two numbers, then that's going to be considered an outlier. Okay, and let me see. And I made a mistake. This should be a plus. So that's wrong because that looked very, very weird. So it was a plus. So 54 plus 1.5 times 19. That's still wrong. 54 plus 1.5 times 19. All right, 82.5. So that sounds a lot better. Okay, so this should be both our lower fence and our upper fences. Okay, so now, yeah, so there was a mistake right there. So this should have been a plus. Okay, so now the next thing is, are there any outliers? So if you look here, we want to make sure that we want to look at numbers, or good numbers have to be between the 6.5 and 82.5. So here are going to be all of our good numbers. So let me put Blue, these are my good numbers. Anything that's outside would be anything that would be considered an outlier. So anything that's bad numbers, I guess. So 6.5, notice that 6.5 is way over here, right? So it seems like we're good until we get to 82.5. Well, 82.5 will be somewhere around here. So the only number that's pretty good is going to be all of these except 87. So 87 is the only one that would be considered to be an outlier. Okay, so this is the only one. Okay. All right, and now here's the next thing. So we want to construct a box plot. Now I'm going to stop right here before the video gets really long. So in the next video, I'll go ahead and construct the box plot for you.